Hello all, hope you all doing great. Welcome back to my channel once again. So in this video, let's cover the topic about the routine checking of boiler burner. It is given in task number 10, competence number 1. So yeah, let's get into the content. So before getting into the content of routine checking of a burner, let's have a quick recap of what we saw about boiler in the earlier contents. So boiler, as we know, it is for generating the steam. And there are two types of boiler, like smoke tube boiler and water tube boiler. Well, the ultimate aim of a boiler is to generate the steam by heating the water. So you just have to heat the water, and that is why we are using a boiler. And how we are heating and how this boiler complies with the IMO standards, like safety standards, with the operational standard, really matters, because anybody can, by heating the water, can generate a steam. But how to do it in a safe way, how we need that operational requirements. Suppose we need 7 bar of steam pressure or 10 bar of steam pressure, how we gonna regulate it? So in a regulated, controlled way is where the real engineering actually matters and happens. So anyways, let's all keep it aside. So this is what about a boiler is about, and how the boiler steam is actually getting consumed. We saw boiler generates the steam we are passing it to the load, like the bunker tanks or wherever, maybe to heat the water, and from there it goes into the condenser. The steam is getting condensed, turned into water, then that is collected in a casket tank, and from the casket tank again we are feeding into the boiler as required. And the water that is used for boiler is chemically treated, because the tubes inside the boiler body is a metal structure. It can get corroded at any time. So to avoid the corrosion, we add certain chemicals into that water that is being fed to the boiler. And this water is like a closed loop, like, yeah, the same water is being used again and again. In case if water level is less, we add water, and again we treat it with the chemicals. So this is how. And we are using feed water pumps. So yeah, this is just a quick recap. I don't want to take too much of your time. So regarding burner, before getting into the burner, I have taken a short video of my ship's burner that is present on board, so that rather than just explaining you about a burner, directly getting into the content, just have an idea, like have a look like how a burner looks. So yeah, let's go. Hi, so basically this is the boiler, and the blue color part on this metallic structure, even the blue is a metallic part, but on that silver, the blue part is the burner. Okay, that whole complete blue color set is the rotary cup burner set. And on the top you are seeing the combustion air fan motor, which sucks the air. For ignition we need air, fuel and heat, and as a part of it, the one which is responsible for air is that particular motor. So it sucks the air, and that air is controlled using that black box, that is the air servo motor. Okay, so basically from air combustion motor, the air servo motor controls the air and send it to the burner. This motor is the burner motor that is responsible for injecting the oil, and that oil is controlled using the oil servo motor. So basically the motor that is responsible for air, we see the oil we saw. Now we need to ignite them. So that particular area, this particular unit is called the pilot burner, where the oil is injected, and it is the place where the oil will get ignited using these two black cables that is from the ignition transformer. Okay, the ignition transformer cables are actually passing the power or current to the electrodes, and once the ignition comes, that is pickup, that is sensed using a flame eye. So those are the flame eye scanners. Okay, so basically this complete set is actually the burner part, and in my ship this is a rotary cup burner. That is why the burner motor is actually rotating the cup kind of burner through which the oil is splashed inside, and which is getting ignited using those ignition transformers. Okay, so yeah, this blue part. I hope that visual video or visualization for you would be more helpful. Now, as you know, like from the top there is a combustion air motor, air servo motor, then burner motor, oil servo motor, then flame eyes, pilot burners, like ignition, the one which gives that ignition or spark. So other than that, there is nothing much in the burner. So what routine check you're going to do? Everything, the motor has to operate perfectly. So you will do a normal motor check, right? Mega testing, foundation bolts are good, the air gap of the motor and rotor, if at all, like maximum that you can do on a motor, you will be doing that. And regarding the flame eye, is it's like it has to sense the light properly, right? So that area that is sensing needs to be cleaned. You have to clean it, make sure that that is free of dirt, free of blur kind of minute particles, what I would say, like a soot kind of particles. So it should be free of that. Make sure it is free of such particles. Then what else? The burner, which gives that ignition, which gives that initial spark, you know, that spark is coming through an ignition transformer, and you have to make sure that cable is not damaged, and that spark is going to come through two electrodes in the burner. Through two electrodes the sparks are going to come, and as the spark comes in the middle, you're going to have a fuel line. So spark comes, fuel injected, and the flame comes. And once the flame comes, the flame eye senses there is fire, and the operation continues. If suppose the flame eye detects there is no fire, boiler will stop. So you have to make sure first the electrodes are giving spark. To ensure that electrodes are going to give spark, transformer should be in good condition, as well as the electrodes should be at equal distance. For example, I just have this toy with me. So we can consider these are the two electrodes through which spark is coming, and this one through which the fuel will be coming. So through this area the spark comes, and through this area the fuel comes. So these two electrodes have to be maintained at a distance so that the spark ignites the fuel. So the manufacturer has given an advisable distance between two electrodes. So only thing is, the distance between the electrode should be matching the standards or settings of the manufacturer. And if at all there is a problem in an ignition transformer, you have to figure it out how and what. Sometimes if the ignition cable is grounded, then the spark won't come. So even though the transformer is good, you know how you ensure that the transformer is good? Transformer, as we know, it is only a primary, it has only primary winding, secondary winding. A winding is a one which have like only two ends. How I can say, like I don't have any. Okay, if suppose consider this is primary and this is secondary of the transformer. So primary is the where you give the input. Suppose 220 volt you are giving, and you are going to get like more than 1000 volt in an ignition transformer. So 220 volt you are giving this side, and 1000 volt you are getting this side. So 220 is input, phase and neutral, so only two end you are going to have. So a winding is a coil where you should have the continuity. Similarly, on the secondary side, you're gonna get 1000 volt through two ends. So it is actually a wire with two ends which should be having continuity. So the basic check on a transformer is that you have to ensure it has continuity. Okay, if you have continuity, then the transformer is good. If you don't have a continuity, then the transformer is not good. And even if you have continuity and if your electrodes are not giving spark, maybe the distance of the electrodes is far away from the manufacturer's requirement, or maybe if the ignition cable from the transformer is grounded, then you don't get a spark. So basically, during the routine checking in the burner end, make sure the motors are good, their mega values are good. Ensure the flame eye flame eye is free of dirt, and the electrodes are at equidistant. If suppose, and as I told you over here, between the electrodes you are going to have a burner, and this burner, I mean the fuel, if this is the two electrodes, fuel will be coming through this, where when this two ignites and fuel comes through this, the fire comes. Okay, So what happens is the fuel from here that is coming, we don't want to directly just inject it. If we can atomize it, like if we can make like a small smoky fuel rather than directly passing the liquid fuel, if we can atomize it, it is so better. So you will be having an atomizer at this particular area, an atomizer, a netted small mesh through which the fuel has to come. When it comes through that, it will not be full liquid, it will be like splashing a minute particles with smoky thing. Okay, and in that condition, if you give the spark, it will fire. Okay, so you have to make sure the atomizer is clean, and these are all the routine checks you have to do. And how often you do is based on the PMS, the plant maintenance system, and based on the manufacturer. And moreover, sometimes your chief engineer uses HFO, sometimes he uses diesel oil. So if they're going to use a diesel oil, yeah, you don't have to have go for any maintenance in the burner, especially for cleaning the burner or atomizer. But of course, yeah, the electrodes they have to go for. Whereas if they are using HFO, the routine cleaning is very often, because HFO viscosity, you know, it is very less. So yeah, in that case, it depends on the fuel and the oil and the viscosity also. So based on this, all the routine check depends. So this is all about the routine checks of the boiler burner. Thanks for watching the video.